Hello everyone, I would like to welcome you in our online tutorial class of mathematics as we have been talking about exponential equation from our last class. So let's continue that one. So formally I would like to welcome you all. In our last class, if you have remembered, we have there talked about different axioms of exponential equations, and after that we did few questions that how we can apply the axioms of exponential equations in our various calculations. So now continuing the same thing, now let's continue here also. Now today we are going to talk about a few questions where we can uh, excel our idea furthermore of exponential equation. Now let's get started. So the first question that we have here is 4 to the power x equals to 1 by 8. Now, if you see this question precisely, there is base 4 on the left hand side and there is 8 on the right hand side denominator. So that means 4 and 8, they, do they have any common thing? Yes. So they both are the multiples of 2. So that means, is it possible that this 4 can be expressed in terms of base 2? Of course, 4 can be written as 2 squared. And how about this 8? Yes, 8 can be also written as in terms of 2, that is 2 cubed. So that means if we apply the case of making base same, then left hand side will be 2 to the power 2 in terms of in place of base 4. But there is power x already of x 4. So that means if we apply the idea of power law, then eventually it will be 2 to the power 2x. That's right. So now we have sure that on the left hand side there is 4 to the power x. It can be written as 2 to the power 2x. Whereas on the right hand side 8, it can be written as 2 cube. So we have done the same thing in our first step. All right. So 4 to the power x has been expressed in terms of 2 to the power 2x, and 8 has been expressed in terms of 2 cube. Now, if you have remember our previous class, this 2 to the power 3 is there. So if we try to take this up on the numerator, then how much it will be? That's right, it will be 2 to the power minus 3. Since there is already 2 to the power 3 plus 3, so when it goes to the numerator, it will be 2 to the power minus 3. Now, a very crucial step has arrived here. With bases 2 and base 2 on the left hand side and right hand side, there is no any other extra terms has been added here. So you cannot find, or we cannot find any other terms that is being attached with base 2. So in this case, this is pure case of applying exponential equation rule. So that means we can easily apply the axioms. There is base 2 on the left hand side and there is base 2 on the right hand side, and there is equals to sign in between them. That means, yes, the axioms of exponential equation can be easily implemented. That means if the bases are same, then yes, powers will be same. That we can take the help of axioms of exponential equation. As you can see on the box also, in the box also, there is a to the power x equals to a to the power y. So here also, as the bases are same and there is equals to sign in between them, then powers will also be equal, or powers also can be equalized. So that means here there is base 2 and there is also base 2. So when we equalize the power, then it will be 2x equals to minus 3. That's very good. All right. So as we are actually solving this exponential equation, that means we are trying to find the value of x. Yes, the value of x will be minus 3 by 2. Well done, everyone. I hope that you have understood the idea in a very precise manner. Now, let's proceed ahead. Let's go to our second question as well. Now, in our second question, as you can see here that there is base 10 on the left hand side, and but right hand side seems a little bit complex. That means 1 by 0.001 has been given here. All right. You know, some of you might be thinking that this 10 should be expressed in terms of lower base. That means 2 times 5. But let's wait for a while. Let's wait for a while before we break down this 10 in terms of 2 into 5. Let's focus on first right hand side, that how can we express this decimal in terms of whole numbers, okay, without a decimal number. So 0.001, is it possible that 0.001 can be expressed in terms of scientific notation? Yes, 0.001 can be written as 10 to the power minus 3. That's very good. Well done. Well done. So, or else you can do one thing, 1 by 0.001. You can put in your calculator also, so that there also you will get the same value, that is 10 to the power minus 3. But the whole value will be 10 to the power, 10 to the power 3 will be there. Actually, when 1 is divided by 0.001, all right? So that means now we can express this 0.001 as 10 to the power minus 3. Now, let's proceed ahead. As we have done this kinds of idea a little bit in question number 8, you can see here that there is 1 by 2 to the power 3. So when we sent, or when we took this 2 to the power 3 on the numerator, it will become 2 to the power minus 3. So with the help of same idea, if we take this 10 to the power 3 on the numerator, it will be, yes, 10 to the power 3. Minus will be changed into plus. That's right. So see, here is base 10 on the left hand side, and there is also base 10 on the right hand side. That's why I was saying that it is better not to express in terms of base 2 and 5, in terms of 2 and 5. All right. So now there is base 10 and there is base 10. So again, here is the condition of applying exponential equations axiom. That is, if the bases are same, then yes, powers can be equalized. That's the basic idea that we have just talked also. Now, so 10 to the 3y minus 3 equals to 3. So powers will be equal. So now, as we are looking for the value of y, so 3y can be equals to 6, because we know that when this minus 3 of the left hand side will goes to the right hand side, then it will be added with the right hand side already 3. So that means 3 plus 3 will be 6. So 3 ones are 3 and 3 twos are 6. In this way, we have found the value of y. So I hope that you all are clear in this part also, that how we can find the value of y in case of question number B. All right. Now let's proceed ahead. Let's go to some other calculation as well. Now, uh, while we are looking at this question number C, it seems a little bit complex, but let's not worry. We'll discuss about this in a very precise manner that each and everything will be clear to us. All right. So now, if you see the left hand side, there is base root over 5. Whereas if you see the right hand side, there is base 25. Now, there is root over 5 and there is 25. Which one seems very easy to break down? Of course, 25 seems very easy to break down, isn't it? 25 can be easily written as 5 square. Good. Whereas root over 5 also can be easily written in terms of base 5. As we are talking about exponential equation and before that laws of indices, then can we express this root over 5 in terms of base 5? Yes. If you have remember your exponential laws of indices part, then if there is root 5, then root can be expressed in terms of power, isn't it? So root over 5 can be written as this is a square root, so it can be written as 5 to the power, yes, that's right, it will be 5 to the power 1 by 2. So, but there is already power. If you see in our particular question, there is already power 3a minus 1. So that means, according to the power law, power to the power will multiply, isn't it? So power 1 by 2 and power 3a minus 1, they will multiply. So eventually we'll get 5 to the power 3a minus 1 by 2. Yes. Numerator 1 will multiply numerator 3a minus 1, and denominator 2 will multiply denominator 1. So 1 times 3a minus 1 as a 3a minus 1, and 2 ones are 2. That's right. So left hand side can be written as 5 to the power 3a minus 1 by 2. Whereas we have already discussed that the right hand side can be written as 5 square. to the power a plus 1. Okay, so you can see the same thing here. You can see in your box, in this box also, there we have written if mth root of a to the power n is there, then it can be written as a to the power n whole to the power 1 by m. Okay, as we had a square, as we have square root here, so it will be 1 by 2. Okay, so I hope that you all have clearly understood the idea that we have discussed here. Okay, so this root over 5 can be written as 5 to the power 1 by 2, and there is already power 3a minus 1. So 1 by 2 power and 3a minus 1, they will multiply and makes eventually 3a minus 1 by 2. And on the right hand side there is 25, so 25 can be written as 5 square, and as there is also already power a plus 1, so 2 and a plus 1 will multiply with each other. Now, here also we have arrived at the same condition of using the axiom of exponential equation. There is base 2, base 5, and there is also base 5. Yes? So, both bases are being same. That means, yes, of course, we can equalize the power. So, the power of left hand side 5 is 3a minus 1 by 2, and power on the of the right hand side 5 is 2 bracket a plus 1. So you can see in this step these both powers has been equalized. Now as we are looking for the value of a, now what we can do, can you guess? Yes, of course, we can do the cross multiplication first. So when this 2 can be, when this 2 will be cross multiplied with the right hand side, it will be simply 4. Yes, all right. So further simplification, on the right hand side 4 bracket a plus 1 will be 4a plus 4. Now here we can see that in the left hand side there is 3a, and in the right hand side there is 4a, and or further 1 and 4 are also there. So according to the case of like terms keeping together, now let's keep the like terms together. What we have done here is 3a and 4a, they had been they are taken together, and 4 and 1 also they are taken together. Now 3a minus 4a is simply minus a, and 4 plus 1 is 5. So now as we are looking for the value of a, so therefore the value of a becomes minus 5. Well done, everyone. I hope that you all have understood the idea that we are actually trying to discuss here. Though the question seems a little bit difficult, but actually it is not so difficult if we have clear idea about how to deal with the root. That means how root can be expressed in terms of power and cross multiplication part, then the things will be easy. And most important thing is the axiom of exponential equation. That means if the bases are same, powers will be same. That's the idea. Now let's proceed ahead. I hope that you have quite clear about the idea that we have discussed in this question number C. Now let's go to the next calculation as well. Now solve. Okay. Here 5 to the power x plus 1 plus 5 to the power x equals to 150. All right. Now a little bit new thing that you can see here, that is plus sign has come. All right. Now let's talk about these kinds of questions also precisely. All right. Now 5 to the power x plus 1 is here, and here is 5 to the power x, and there is plus sign in between them. So as there is plus sign, we cannot use the product law, isn't it? So let's think further. Let's think further. Is it possible that 5 to the power x plus 1 can be broken down? That means, can we write 5 to the power x plus 1 as a 5 to the power x times 5 to the power 1? Very good. Yes, it can be written easily. So I have applied the same condition in our first step. See, what I have done here is I have just broken down this 5 to the power x plus 1 as a 5 to the power x times 5 to the power 1. Now, if you see these things precisely, this plus this 5 to the power x times 5 to the power 1 plus 5 to the power x. Is it possible to have certain thing common? Yes, we can easily take out the common 5 to the power x. So from 5 to the power x times 5 to the power 1, if we take out 5 to the power x common, then yes, there will be the remaining 5 to the power 1. It's a simple division process, plus when we take out 5 to the power x from this 5 to the power x, what will be the remaining? Yes, it will be 1. Yes. So when we take out 5 to the power x common from the left hand side, then 5 to the power 1 plus 1 will be there. Whereas the right hand side is already 150. There is no any change. Now you can see the same step that we have done here. Okay, 5 to the power 1 is 1 itself. Now 5 plus 1 becomes 6. That's right. So the left hand side is 5 to the power x times 6 equals to 150. Now, easily we can send this 6 on the right hand side. And as it is being multiplied form, as it is in the form of multiplication on the left hand side. So when 6 goes to the right hand side, it will be in the form of divide. That means 150 will be divided by 6. That's right. So 150 has been divided by 6. So the division of 150 by 6 will be 25. So now as we are clear that this 25 can be easily written in terms of base 5, isn't it? So 5 to the power x equals to 5 square. Now again we have arrived at the step of using the axiom of exponential equation. That means if the bases are same, yes, the powers will be same. That is, the value of x becomes 2. Okay, I hope that you have clearly understood the idea that we have discussed here. Now let's proceed ahead and let's talk about question number B also. Now, here also in this question number B, we'll apply the same condition that we have just discussed in question number A. Okay, so 3 to the power x plus 1. So when we try to break down this one, then it will be 3 to the power x times 3 to the power 1. Similarly, when we break down 3 to the power x plus 2, then it will be 3 to the power x times 3 square, or 3 to the power 2. Now, if we look at the right hand side, there is mixed fraction is here. So, as we know that the mixed fraction can be easily expressed in terms of improper fraction. That means 3 times 1 plus 1 by 3. That's right. So, eventually it will be 3 ones are 3, 3 plus 1, 4. The improper fraction for the given mixed fraction is 4 by 3. That means, let me repeat it again. If you are a bit confused, this and 3 and 1, they will multiply, and after the getting the multiplication value, this one will be added. Okay, so that means 3 ones are 3, 3 plus 1, 4. 4 by 3. That's the improper fraction for given mixed fraction. So as we have discussed earlier, you can see here that we have separate the bases on the left hand side, and on the right hand side we express the given mixed fraction in terms of improper fraction. So now we'll repeat the same thing. That means on the left hand side we'll take out the common. That's right, we'll take out the common 3 to the power x. So when we take out 3 to the power x on the right hand side, left hand side, then 3 to the power 1 will be remaining from the first part, that is 3 itself, and 3 square will be left in case of second part, that will be 9. So as 3 plus 9, it's in case of addition form. So 3 to the power x times 12 equals to 4 by 3. Now, as we have discussed in previous question also, this 12 will comes down of the right hand side to divide 4, or to divide 4 by 3 also can be said. So that means 3 to the power x equals to 4 by 12 times 3. Now, if you see these things precisely here, this 4 and 12 can be cancelled easily, isn't it? So 4 ones are 4, 4 threes are 12. So that means on the left hand side there is 3 to the power x, and on the right hand side there is 1 by 3 times 3. Can we write this 3 times 3 in any other power form? Yes. So this 3 times 3 can be written as 3 square. Well done. Yes. This 3 times 3 can be written as 3 square. Now, as we have been discussing about this idea in previous questions also, this denominator of right hand side 3 square can be taken to the numerator. Yes, that's right. So when we take this 3 square of the right hand side denominator to the numerator, it will be 3 to the power minus 2. Good. So again at the eventual step of using the axiom of exponential equation. That means bases are same, powers will be same. That is, the value of x will be equals to minus 2. Well done, everyone. I hope you have understood this idea also very precisely. Even though question seems a little bit complex, but the overall idea is very much related and very much easy. All right. Now let's go to our next question, question number C. Okay. So arriving till this step, I think you have obtained so many ideas. Okay. So without wasting further time, let's move ahead. Now here also in this C number question, you can see a unique thing here, which is different than A and B. In A number, there was plus power, and in B also same. But here in C number, you can see powers are in negative form, plus. But please everyone, no need to worry. In case of negative powers also, only some of the things will be different. Otherwise, the overall idea will be remains the same. Okay, so as we did in the previous A and B number, here also let's separate the bases. So here you can see easily that I have separated all the bases. Now as usual, let's take out the common. Yes, 3 to the power x. So when we take out the common 3 to the power x, then from the first part it will be 3 to the power minus 2 will be remaining there, and in the second part 3 to the power minus 3 will be remaining there. And this time we don't need to do anything with the right hand side. Now do you think that 3 to the power minus 3, this 3 to the power minus 3 minus 2, 3 to the power minus 2 is minus 9? No, absolutely not. Everyone, please make yourself clear for this. 3 to the power minus 2 is not minus 9, but according to the laws of indices, 3 to the power minus 2 can be written as 1 by, that's right, 1 by 3 square, whereas 3 to the power minus 3 also can be written as 1 by 3 cube. That's very good. I hope you all have understood this idea very clearly. So the same thing we are going to do on the next step. That means 3 to the power minus 2 is going to be written as 1 by 3 square, and 3 to the power minus 3 is going to be written as 1 by 3 cube. Okay, so the same thing you can here see here. Now further simplifying, now our focus should be in this term which are inside the bracket. 1 by 3 square is 9, good, and 3 cube is 27, good. So the same thing you can see here. Now let's take the LCM of this 9 and 27. Do you have any idea what is the LCM of 9 and 27? That's right, the LCM of 9 and 27 is 27 itself. So when we take the LCM inside the bracket term, then the numerator will be 3 minus 1. So if you need a little bit explanation, it can be done. So as we have LCM 27, so when 27 is divided by first denominator 9, the answer will be 3. Yes, because 9 3 is 27. So that 3 will multiply the corresponding numerator. That means 3 ones are 3. That's why we have written 3 here. And in the second case, again, when LCM is divided by the second denominator 27, so when LCM 27 is divided by denominator 27, it will be 1. Answer. So 1 times this corresponding 1 will be 1 itself. So in this way, on the numerator, there has come 3 minus 1. So now, with a simple understanding, 3 minus 1 will be 2. So 3 to the power x times 2 by 27 equals to 2. Now, let's see the things precisely. As we know that, and we have been doing that, these terms, except the power in x terms, we are going to normally send it on the right hand side. So 22 by 27 when goes to the right hand side. So 2, this right hand side 2 is going to be divided by 2 by 27, isn't it? Whatever the terms on the left hand side, this 2 by 27, that when it goes to the right hand side, it will divide it. So you can see the same thing on your next step. See here, this two has been divided by 2 by 27, but we know that this 27 will go up. Very good. So 27 will go up. That means now we have obtained a very simplified form. That means this 2 and 2 can be cancelled. Now the remaining is 27 only, and we know that 27 can be easily written as in terms of base 3. Yes, so that means 3 QVs for 27. So eventually, now we have arrived at the stage of using the axiom of exponential equation. That means if the bases are both 3 and 3, then powers also will be equal. That means the value of x equals to 3. So in this way, we have solved question number C, and we have got the value of unknown variable x as a 3. Okay. Now, as we have talked about various types of question today, now there are few reflective questions, few revising questions, which can be very much useful for you to understand and replicate the idea that we have discussed previously. Okay, everyone, solve the following exponential equation. There are few questions that you can practice to understand the exponential equation and how we can solve it. I have included some previous questions also, and from questions from this time also. So it will be helpful for you to practice it and enhance your understanding. Okay, so I hope that you all have understood the idea that we have discussed here. So in our next class, in our next video also, we'll be continuing our this part of exponential equation, where we will be talking about more interesting questions of exponential equations. Okay, thank you everyone. Thank you for being with us, with me, and then thank you. You have understood all the idea in a precise manner. Thank you.